Welcome to sixth grade math. That was your homework that was due today. Get ready for the lesson. The table lists different animal species and how many of each type are endangered. So we look over here, U.S. endangered species. This is species, so amphibians, there's 13 that are endangered, and so on down the list. Which species has the most endangered animals? So if we look down at the frequency column, look down, 76 looks to be the greatest number. So birds was 76. Which species has the least endangered animals? So if we go over here, what's the lowest number in the frequency column? It appears to be amphibians at 13. What might be an advantage to organizing data in a table? You can find exact values. So that's just one answer, right? Another answer might be it's easier to find data. Are there any disadvantages to organizing data in a table? A table is not a visual graph. So while I can look over here and I can read down the frequency column fairly quickly, I might be able to see it quicker with some kind of picture. We have some definitions. The first one is data, pieces of information that are often numerical. Graph, visual way to display data. A bar graph, used to compare categories of data. That's a bar graph. And it's the same data from the previous slide where it lists the endangered animals. Scale. Scale is written on the vertical axis. So that's on the left side where you see the 0, 10, 20, 30. It includes the least and the greatest number. So the least number is 0, the greatest number is 80. That's the vertical axis. And that's the scale. Intervals. The scale is separated into equal parts. On this scale, the intervals are 10. So you look at between 60 and 70, that's an interval of 10. And then categories are written on the horizontal axis. That's the horizontal axis. And those are the categories: amphibian, birds, fish, mammals. The frequency, number of times an item occurs. So the frequency of endangered birds is 76. Scaffolding questions. So we have a table and we have a graph. Compare the table and the graph, and it looks like it's population by region. What does the bar graph show? The populations of regions in the United States in the year 2000. So that's stated right in the title of the bar graph. About what percent of the population lives in the South? So if we go over and we look at the South, it's about 35%. And how would you figure that out? You would add up all of the, well, it's 36, right? So it's about 35%. And the table contains data, the same data as the bar graph. So if you look at the Midwest, it's 23%, and then you get 23% on the bar graph. It's just over 20. You can do that right down the line. If I asked you which region had the least population, which graphic would you use to get the information quickly and why? So you could scan down through the table, or you could just look over at the bar graph for the shortest bar, and you know that it would be the Northeast. And their sample answer, it's clear which bar on the graph is the shortest. I'd have to look at each number in the table and compare them. So here's the thing. You could look at this table. There's only 4 different categories. So it's not super hard. But imagine if you had a table with, say, 20 categories. The visual of a bar graph is going to be much quicker. Bar graphs can be created so the bars are vertical or horizontal. Thus, the terms vertical bar graph and horizontal bar graph are used. Here's a vertical bar graph, and it's just like the one we just saw. In fact, it is the one we just saw, where the bars go up and down, vertical. And then we have a horizontal bar graph where the bars are laying on their side and they go across horizontally. So now you have to fill in the axis titles on the cheat sheet. Example, make a bar graph of the data, then compare the number of students who prefer email to the number of students who prefer text messages. So here's our table, and the bar graph's here for us. So 10 students prefer email, 12 prefer phone, 4 prefer text message, and 2 prefer instant message, meaning on some kind of social media on your computer. So now we look at the bar graph that's right beside it, and you'll notice that the email is at 10, the phone is at 12, the text message is at 4, and the instant message is at 2. And then notice along the bottom it says form of communication. That's the 4 different forms. And then up the side, beside the numbers on the vertical axis, it says people. Right, so that tells us that 2 means there are 2 people. So step 1, decide on the scale and interval. So that's been decided. Notice that these are all multiples of 2. So that was an easy one to decide. And then step 2, label the horizontal and vertical axis. So that's what I just talked about, people and form of communication. Step 3, draw bars for each form of communication. The height of each bar shows the number of students. So we're going to do these together in the Excel, not Excel, in Google Classroom. There's a worksheet, and it's blank. So if you're not in class, you're gonna need to work on that with me or one of your classmates. Step 4, label the graph with a title. So we've labeled it preferred form of communication. And the height of the bar for email is about twice as tall as the one for text message. So about twice as many students prefer email than text message. So email 10, text message 4. You know that if you double 4, 10 is still greater, right? So you could do it from the table, or you could do it from the bar graph. See, the bar graph is going to give you the quick visual on which one is greater. Check your progress. Make a bar graph of the data. Compare the number of students who chose chocolate to the number who chose strawberry. So the table gives us the information, the flavors of ice cream, and chocolate 12, strawberry, chocolate chip 7, strawberry 4, vanilla 9. So if we make the bar graph, we have favorite ice cream flavor. Actually, I'll just follow the steps. Decide on the scale and interval. So the data include numbers from 4 to 12. So we're going to go 0 to 14 with intervals of 2, just like the last one. Step 2, label the horizontal and vertical axis. So we have people on the vertical axis, and on the horizontal we have flavor. Step 3, draw bars for each form of communication. The height of each bar shows the number of students. So chocolate, 12, so it's right on the 12. Chocolate chip is 7, so we're going to go halfway between the 6 and the 8. Strawberry is 4, so it's right on the 4. And vanilla is 9, so that is halfway between 8 and 10. Step 4, label the graph with a title. So we're going to label it favorite ice cream flavor. And the height of the bar for chocolate is about 3 times as tall as the one for strawberry. So about 3 times as many students prefer chocolate than strawberry. And that's how you can figure it out from the visual. But if you look at the table and you see chocolate is 12 and strawberry is 4, you know that 4 times 3 is 12. So strawberry is 1/3 of chocolate, or chocolate is 3 times that of strawberry. Line graph used to show how a set of data changes over a period of time. So by observing the upward or downward slant of the lines connecting the points, you can describe trends in the data. So baseball game attendance, this is a line graph, or a line graph and a bar graph are meant to show different types of data. So bar graph compares amounts in a single time period. For example, a bar graph might show the attendance on a given day at a Major League Baseball stadiums around the country. But a line graph, by contrast, shows how data changes over time. A line graph could show the attendance at a particular baseball stadium over a month-long period. This line graph shows the attendance over 25 years and how it has increased. Example, make a line graph of the data below. Describe the change in Earth's population from 1750 to 2000. So first we have to figure out, okay, we see the years in the column on the left. Then the population is in millions. So in 1750, there were 790 million. In 1800, there were 980 million. So in 1850, it becomes 1,260 million. So if we convert that to a bigger number, it would be 1.2 billion people. So then in 2000, it's 6 billion people. So here's our line graph, and you'll notice that on the horizontal axis, it says year for the title, and on the vertical axis, it says population, and it has 1,000, 2,000. Those are all in millions. So what it really means is 1,000 million is really 1 billion, and then so on up 2, 3, 4, 5, 6, 7 billion. So you can see that in the most recent years, the population growth is much greater and quicker. So step 1, the data includes numbers from 790 million to 6,080 million. So a scale from 0 to 10,000 million in an interval of 1,000 million are reasonable. Remember, we don't need to see the exact detail on this, we just need to see the trend. Step 2, label the horizontal and vertical axis. So as I mentioned, the years on the horizontal and the populations on the vertical. And step 3, draw and connect the points for each year. So we would put those on the graph, and then we would draw the line. We would put the points on the graph, and then we would draw the line. And then step 4, label the graph with the title. So it's just, we're going to call it Earth's population. Earth's population has increased drastically from 1750 to 2000. Check your progress. Farming. Make a line graph of the data. Describe the change in the number of North Carolina farms from 2001 to 2005. So 2001 is 55,600, and it looks like every year there's less farms in North Carolina. And if we go ahead and make the graph, the line graph, first we're going to include, the data includes numbers from 50 to 55,600. So a scale of 0 to 60,000 and intervals of 2,000 makes sense. So, but what you're seeing is, you're seeing 44,000 to 60. So it's a piece of the line graph. Step 2, label the horizontal and vertical axis. So we've done that with farms on the vertical and year on the horizontal. Draw and connect the points for each year. So we're going to draw the points, and then we're going to draw the line between them. And step 4 is label the graph with the title. So we're just going to call it North Carolina Farms, or NC Farms. And notice that this makes it very clear to us that the number of farms in North Carolina is declining. The chart shows a steady decline, with the largest decline being between 2004 and 2005. Additional example, animals. Make a bar graph of the data. Compare the time it takes for a rabbit to be born to the time it takes for a camel to be born. So this means gestational of selected animals. So how long is it in the womb? So we have the animals and we have gestations. Step 1, decide on the scale and interval. So the numbers are 31 to 406. So the scale 0 to 400 and an interval of 100 are reasonable. So if you look on the vertical axis, you'll see 0, 100, 200, 300. That's our intervals, 100s. Step 2, label the horizontal and vertical axes. So generate gestation of selected animals, and animals are on the horizontal. Step 3, draw bars for each form of for each length of gestation. Step 4, label the graph with the title, so gestation of selected animals. It takes about 13 times as many days for a camel to be born as it does for a rabbit to be born. Additional example, water consumption. Make a line graph of the data below, then describe the change from 1960 to 1995. So this table has a little bit more data than what we've been seeing, and I believe that we're starting to see why a picture or graph, like a line graph or a bar graph, may be more useful. You know, when you're looking at a table with 3 or 4, maybe even 5 pieces of data in it, it's not really difficult to look at the table. But when you start looking at one that's got, you know, upwards of 10 pieces of data and even more, the picture becomes more valuable. So you'll notice the left column is the year, the right column is the water consumed per day, and it is in billions of gallons. So in 1960, U.S. water consumption was 61 billion gallons per day. And if we do our line graph, the data is 60 billion to 100 billion, so a scale of 0 to 120, with an interval of 20 billion. Step 2, label the horizontal and vertical axes. Step 3, draw and connect the points for each year. Step 4, label the graph with the title. So all of those things have been done. We will do this together in class on the homework. And the water consumption increased from 1960 to 1995, with a slight dip in use between 1980 and 1995. Here's your homework for tonight. This is a little different than most homework. We are going to work together, Google Sheets, and we are going to create tables, enter the data, and then create the graphs. And then you will do the homework assignment on your own in Google Forms. So there's 2 parts. There's making the graphs we're going to do together, and then on your own you're going to analyze the graph and enter that into Google Forms. Thank you and have a great night.